This is your first lesson on performing operations on functions, including function composition. All these notes can be found in Glencoe 7.7, so please make sure that you're filling in aspects that I do not address. For example, I will not be telling you what the definitions are on your vocab. I will not be filling in the chart that is also on the top of this. I will be focusing in on examples. So let's start with example number 1, where we are adding and subtracting functions. I'm given two functions, x squared minus 3x plus 1, he is f, and g of x, 4x plus 5, and I'm told to do the two operations to them. F plus g of x, that's just another way of me saying add this function to this function. When adding functions, it's important just to combine like terms. So I know that my negative 3x and my 4x are going to be like terms, and my positive 1 and my positive 5, they will also be like terms. That's why I'm going to have x squared plus negative 3x plus 4x. That's going to combine to create just an x. And then I'm going to have a positive 1 plus a positive 5, creating a positive 6. Okay. There wasn't a whole lot of work to show on that one. I verbalized a lot of it, so make sure you listen to what I had to say. Now the other one was subtraction. That'll take some work to be shown because it'll be very important that you recognize it's an entire function being subtracted. It's not just one single term. So I'm going to rewrite function f, x squared minus 3x plus 1, and I'm going to subtract the entire quantity of g. Both the 4x and the positive 5 are being subtracted here. So I know x squared has nothing to combine with, but I have negative 3x subtract a 4x. Negative 3x subtract 4x gets me negative 7x. And then we're going to have a positive 1 subtract a positive 5. 1 minus 5, that's going to get me negative 4. Once again, I didn't show a whole lot of work here. It was very important for me to articulate the operation that was happening. So it's really up to you. Do you need to show the distribution of the negative, or can you verbalize it in your head? Looking at example 2, now we're going to be multiplying and dividing functions. So multiplication, you can approach it a couple different ways. If you like the box method, you can use the box method. If you like the vertical method, you can use the vertical method. Otherwise, you can just stick to the old traditional distribution ideas. So f times g, I'm going to have my entire quantity x squared plus 5x minus 1, and I'm going to multiply him by the entire quantity of 3x minus 2. Distribute my x squared into both of those, so I'm going to get x squared times 3x is 3x cubed. X squared times negative 2 gets me negative 2x squared. Now I'm going to do my positive 5x and distribute him into both of them. 5x times 3x, that's going to get me 15x squared. 5x times negative 2, that's going to get me negative 10x. And notice that I'm starting to align things that are going to be like terms, okay? Last one is negative 1, and you distribute him into both of those. So negative 1 times 3x gets me negative 3x, and lastly, negative 1 times negative 2 gets me positive 2. So my final answer, 3x cubed, negative 2x squared, and a 15x squared will combine to become a 13x squared. A negative 10x and a negative 3x create a negative 13x. And lastly, we have the positive 2, and here is our multiplication. All right, so now we have f divided by g. Whenever you have division, you need to remember some of your properties of rational expressions. The only thing you're allowed to cancel out of rational expressions are factors, okay? So we have f divided by g, x squared plus 5x minus 1 over 3x minus 2. This is what's going to be. I cannot simplify it any further because there are no common factors amongst the top or the bottom. Looking at the top, I can't factor him. Looking at the bottom, I can't factor him. So the only thing I need to be sure to state is what value for x I'm not allowed to be. This is going to be my domain restriction. And I can do this simply by setting my denominator equal to 0. Basically what I'm not allowed to equal, okay? I'm going to add 2 to both sides, so 3x can't equal 2, and then divide by 3. So x cannot equal 2/3. So that also needs to be a component of my final solution because that is a domain restriction of its function. Alright, so now we're going to do a throwback to some relations. Those were visited in Algebra 1. Relations are just going to be a set of ordered pairs. And we're told to do function composition. We're going to do f of g as well as g of f. Okay? So first let's look at f composed of g. Everybody always laughs and says fog. So I'm going to take my ordered pairs, okay, from function g, and I'm going to plug them into function f. So the first thing I'm going to plug in is f, and I'm going to plug in g of, my first coordinate has an x value of 5, okay? So it's really telling me, well, g of 5, that's equal to 7. So then it's asking me, well, what's f of 7? Well, looking at relation here, the y value for 7 is going to be 8. Now I'm going to keep proceeding and going through all the coordinates. The next one I'm going to do is doing g of 3. Well, g of 3 is equal to 5. So now I'm really looking at f of 5. And according to here, he's equal to 3. Continue on, see if you can do the rest yourself for f composed of g. Now, let's look at g composed of f, and we'll do some together. Let me erase all my circles up here, that way it'll be a little bit easier for you to see. G composed of f. First, let's plug in an f of 7. Well, f of 7 is equal to 8, so I'm really doing g of 8. Notice that in my function g, nowhere do I have a value of x where it's 8, so this is undefined. See if you can do the rest. Now let's move into example 4, where we're actually composing functions. It's really just going to be the art of plugging one function into the next. So f composed of g and then g composed of f. F composed of g, that just means take function g, all of it, and plug it in for x wherever you see it in f. So for function f, I like to do it like this. Give yourself a big set of parentheses whenever you see an x. Now I'm going to plug in function g here. X squared plus x minus 1. Now all I have to do is combine like terms, which is my negative 1 and my positive 3. So f composed of g is x squared plus x plus 2. Now let's look at g composed of f. G composed of f, that means I'm going to take function f and plug it in for wherever I see an x inside of g. Notice for function g, he has 2 x's. So now I'm going to give myself 2 sets of parentheses to plug in function f. So I'm going to plug x plus 3 in here, and I'm also going to plug x plus 3 in here. So first off, the quantity x plus 3 squared. Remember your properties of exponents, you cannot distribute in your square. You need to simply FOIL it. So when you FOIL it out, we're going to get x squared plus 6x plus 9. And then I have my other components. Luckily for me, it's just adding. So I really just have to combine like terms. So I get x squared. I see a 6x and an x, that creates 7x. And I see a positive 9, a positive 3, and a negative 1. So 9 plus 3, that's going to be 12. 12 minus 1 is positive 11. So these are our two compositions. And notice in B, it's asking for us to evaluate for x is equal to 2. So all I need to do is plug 2 into both my compositions. So f composed of g of 2 is our proper notation. That's our first one of x squared plus x plus 2. I'm going to plug in 2 here, and I'm going to plug them in here. Well, 2 squared is 4, plus 2 plus 2. That's going to get me a value of 8. Now, let's do g composed of f, and we're going to plug in 2 for x. He was this composition, 2 squared plus 7 times 2 plus 11. So we have 2 squared is 4, 7 times 2 is 14, plus 11, looks like I need to zoom out a little bit. 4 plus 14 is 18, and 18 plus 11 is 29. So there are our two evaluations. Last example, and it deals with real-world problems. Let's read it together and create the functions that this problem is asking for. Tyrone Davis has $180 deducted from each paycheck for retirement. So we're first going to create a function about how much money I'm getting after I take away money for retirement. Okay, this is my R function. The total amount of money I'm going to make, let's call him X because I don't know him. Regardless though, I'm going to take away $180 from him. It's a firm amount. Let's keep reading. He can have these deductions taken before taxes are applied, which reduces his taxable income. His federal income tax rate is 18%. All right, here is our next amount of money. I can take that money on my paycheck, aka X, and I'm going to take away 18% of it. Now 18% is 0.18, but it's 18% of my paycheck, which is why I have to multiply it by 0.18. Here are my two functions. If Tyrone earns $2,200 every pay period, here's my paycheck amount, X. Find the difference in his net income if he has a retirement deduction taken before taxes or after taxes, okay? Let's first look at the before. If we're first taking it out from the before, we're going to take away it from the function R. So we're going to have our $2,200 and we're going to take away $180, okay? This is going to leave us with $2,200 or $2,020. Then I'm going to take this amount and take away the tax amount, which is my function T. So 2020 minus 18% of 2020, which is where we end up with the amount $1,656.40. Did you know you just did function composition? This is the composition of T composed of R of X, where X is going to be equal to $2,200. Let's look at the after. We're going to do the taxes and then take that retirement money out of it. This is the function R composed of T of X. Once again, where T of X and X is going to be $2,200. So let's do it mathematically now. We're going to take our $2,200 and we're going to take away 18% of our $2,200. Whatever the answer is, we're then going to plug that into our function R. Well, that amount ends up being $1,804. Function R says take this amount and take away $180, which ends up equaling $1,624. So now we're looking at the differences between these two amounts. The difference between $1,656.40 and $1,624 is a difference of $32.40. So, when we're drawing some conclusions here, who made more money in which situation? Well, it actually makes more sense for him to first take out money for retirement, then pay taxes on it, because he makes about $32.40 more, and we like more money.